Hello and welcome to today's webcast in Germany and Belgium
Yes.
and all the world. So welcome to everyone. Today our topic is everything about surveying the waves of maritime or marine networking. And I have a very special guest with me. Our special guest is Birger from Poynting Antennas. Birger, welcome to our episode here. And
Yes.
yeah, maybe you want to introduce yourself a little bit.
Yes. Thank you, Chris. Thank you for inviting me. I am indeed Birger Hillard from Belgium. I had a German grandmother, so I have some roots in Germany. I
Nice.
also come from marine connectivity, so I've probably met 90% of your challenges during my former career. So I'm talking from real life experience and how to optimize connectivity in the marine world. So I'm happy to share some knowledge here. Thank you.
Thank you very much. Yeah, thanks. And I can say we are working with Poynting Antennas for a very long time now. It's been a very reliable partner for us since I think 2009. That's been very long. So, and we've been experiencing a good time with each other. And now you're very much into maritime networking. But let's talk a little bit about Poynting Antennas, where you come from and how you see yourself, Birger. Maybe you want to tell us something about this.
Yeah, of course. We are a South African manufacturer of 4G, 5G, Wi-Fi broadband antennas. Almost 30 years in the business. We started up as consulting and advising to governmental organizations, military. And then, of course, we decided, hey, we could maybe better make them ourselves. Why are we different as a manufacturer? Of course, radiation patterns for us, those are the holy grail. That is really understanding how the gain of antenna is spread around the antenna, so we can really optimize connectivity. Authentic and trustworthy, what does that mean? When you look at our website or at Chris's website and you see a technical sheet, that's really what you see is what you get. Those are real measured results. No mumbo jumbo, really measured results in our own anechoic chambers. So it's really what it says it will do. Built to last, of course, we use quality materials. That's why we still encounter antennas from over 10 years old working on vessels. And quality by design. At the moment, we have more than 50 patents on antenna electronic designs. So that means our competitors cannot copy us, or they need to pay a lot of money. So our maritime history started before that, when people just started using antennas on vessels, even before they were marine proof. But in 2015, we started with our first OMNI 291 marine antenna. And at the moment, we're at 16,000 plus antennas sold in the maritime world, which makes us quite number one and a trusted brand to give the connectivity to vessels out there.
Oh, wow, that's very impressive numbers you're showing here. So yeah, it shows that you've been working on it for a long time. And I can say from our experience, the quality has always been great. And let's go over to some antenna fundamentals. I mean, a lot of people have seen spec sheets, etc. But I think it's important also to look at the fundamentals again and what makes an antenna good and what are the important factors.
Of course. So what you will always see in our spec sheets is which frequencies the antenna will cover. And it's very important because if you want an antenna to cover 4G, you need to know there are a lot of frequencies that are 4G. So which ones are covered, and that's always in our spec sheet. So an antenna is designed to operate on a given frequency. Could be really specified, but we specialize in broadband because we know 4G, 5G, Wi-Fi, there are different frequencies that need to be covered. But it also means that in certain countries, some other frequencies are also part of the 4G or 5G or Wi-Fi spectrum. So that's also understand these regional differences. And that's also for you. For example, UK you'll still use 450 megahertz on the 4G. Other European countries do not. So you need to check, does my antenna cover this frequency if you're in the UK? Most of our antennas now cover from 617, so 600 to 3800, which is the 5G. So really making it future-proof. Whenever 4G would stop working, you still have 5G and then more, but that will take some time. We, of course, now see in IoT, for example, that 3G is going out. If you had a pointing antenna, you'll probably be able to use the 4G because it's future-proof, it's broadband.
Yeah, got it.
And then, of course, sorry, Chris.
Yeah, I'm sorry. I got this. This is very interesting. I mean, what I understand is that there is different frequencies of different countries depending on the networks. So it's good to have an antenna that covers a wide range of frequencies, so you're safe for the future. Is that what I understand?
Yes, indeed. Not only being future-proof, but what we will discuss later is also how higher the frequency, how less far they propagate into the air. So when you're on a vessel long way, fantastic, Chris. Thank you for that.
Yeah,
so
I just implemented. Let me just explain that here. We see a picture of a coast, and we see which frequency reaches to. So we see that the lower frequencies go farther, and the higher frequencies only reach closer. Correct?
Yes, indeed, indeed. And that's a simple fact of physics. So we have high frequencies. They won't penetrate that far. So I made a little calculation, and it's pure theoretical because we need to understand weather does influence how far electromagnetic waves travel through the air. For example, rain, moist in the air will have a negative impact. That's the same for satellite, as for 4G, as for Starlink, for example. These are all frequencies. Now, if you theoretically do calculations, and that's free space path loss, we call it, then you should say that the 3,500 megahertz, which is 5G, it will travel about 8 to 9 nautical miles. That's 16 kilometers in ideal conditions. Okay. And then the higher 4G frequencies, 1,800 to 2,100, they will travel about 28 kilometers. Yeah. And then what is left after that? Yeah. So even going to 40 to 45 nautical miles, which is 80 kilometers, those are very low frequencies, like 700, 800, maybe 900 megahertz. But there's still signals out there. That's what we need to know. And then combine this with a good antenna, and you will be able to pick up 4G quite some distance out at sea. That's what we need to understand.
I think we'll come back to that later on. We do some real life experience. But we've been talking about the gain, etc., and now we have to understand gain plot and radiation patterns. We see some pictures here on the screen where we see a gain plot diagram and radiation pattern diagram seen from the antenna going outwards. What can you say about this?
Well, let's say gain is probably the most misused spec in a data sheet, and people will brag with it. I have so much gain, but we know there are limits. When you create a high gain antenna, your omnidirectionality will suffer. And as we're talking vessels that are constantly changing direction compared to the cell tower, this is very important. Yeah. So what you see on the left is a gain plot, a two-dimensional gain plot, XY axis, which really states that your gain is never the same on all frequencies, never. It does not exist. You can come close to it with directional antennas, but it does not exist. So what you will obviously see in a spec sheet of antennas is the max gain measured on a certain frequency. But for example, most of the time it will be in the higher frequencies. That means the higher 4G or 5G. That means that high gain is not there when you're far out at sea, when you only have the lower frequencies. So that's important to know. It changes over the frequencies, and antenna brands will only give the max gain out there. What we always do, we give, of course, the max gain, and we also split it up into what can you expect between 617 and 960 megahertz, which are the lower frequencies. You have 0 dBi to minus 0.5 dBi. Yeah. So you see, there's a lot of difference between the 4 dBi peak gain. In this example here, right? It's I don't think even it's a maritime antenna. It's just for the.
And only 214, as far as I.
214. Yeah, we have a similar one in the marine, the 414. Yeah. So you see that different gains are there on different frequencies, and that's something you need to know. So never fall for that high peak gain, because it's
Got it.
probably in the high frequencies and no longer usable far out at sea.
Yeah, and from what I understand, the pattern on the right side shows us how evenly spread the gain is throughout or around the antenna. Is that correct?
Yes, that is indeed correct, Chris. What it means, how consistent your gain is around the vessel. So you're really correct. What does that mean? Because your ship is always moving and always changing direction. So the antenna will always be facing another side compared to the cell towers on shore. So you want a really consistent gain, because else your router gets very fluctuating results. And that means it will have higher speeds, lower speeds, higher. So the router needs to work more. And when a router needs to work more, it's really clear, your internet speed goes down.
Okay,
It's
cool.
like, yeah.
Yeah, so when we look at the next thing here is polarization, meaning in what layer, as far as I understand, the signal goes out from the antenna or from the tower and is received by the antenna.
Yeah. So polarization is just indeed the direction of the wave. Could be the x-axis, the y-axis, the z-axis, whatever. So you have vertical polarization when the wave does like this and comes to you. You have horizontal.
But by this you mean it
polarization.
goes straight up, like 90 degrees straight up from the floor. Yeah.
Yes, indeed. And you have cross polarization. That means you have two polarizations. That means could be 0 and 90 degrees or plus and minus 45. Now we will come back to the advantages on this in the next slide. I'm not sure if, because I think we've all heard about polarization when we have Polaroid sunglasses. Maybe you can show the first video, Chris.
I'm not sure if that starts here. But it's basically, there's a video with the sunglasses where you can see, depending on how you hold the sunglasses, you can see the screen or not see it, because it's like going in the opposite polarization of the screen. Yeah,
so we have the same thing in antennas, because light are electromagnetic waves, 4G, 5G, Wi-Fi, those are also RF waves or electromagnetic waves. So what happens when you have a vertical polarized electromagnetic wave? It comes to you, and when you have a vertical aligned antenna, they will have 100% match, theoretically, 100% match. So that would be good, Now, what happens if you send out a horizontal wave and your antenna is vertical? You have a mismatch of minus 34 dBi. What does that mean, minus 34 dBi? Knowing it is logarithmic and knowing that minus 3 dBi is already half of the power, that's minus 10 to the 7th, I believe. So that's practical isolation. So that would mean that your antenna will pick up nothing. So no connectivity there. So playing with cross polarization anticipates on that loss, that possible loss of polarization mismatch, we call it.
We've been talking about reach of certain wavelengths before, but now there's also other influences on the reach of the antenna signal. And I think we put a picture up here where we show different options or different influences from on the antenna signal. Can you tell us a bit about this?
Yes, so reach considerations, because the question in maritime industry, you will get it, I will get it. I joked with Chris, if they would have given me a beer for every time they ask it, I wouldn't have made 10 a.m. It's how far does 4G reach out at sea? I already gave you a theoretical idea on how you can manage the expectations of your customers. Now we need to take into account the rounding of the Earth. We know since a few years that the Earth is not flat.
It is not flat? Okay.
So I think it starts from 20 kilometers. You can already see an inclination of 1 degree. The density of the base stations out at land. If you're like passing by a nature reserve where there are no cell towers, well, there's no signal. If there are more base stations and they're, for example, elevated on hills alongside the coast, they will of course reach much further.
Yes.
The direction of the base station. I'm not sure if you already looked at the base station. It has normally 3 antennas on it. 120 degrees opening, each covering a side. So are they pointed out at sea or just on the mainland? Can we make a difference, of course. Weather conditions. One of the biggest enemies of electromagnetic waves is water. So moist in the air, fog, rain, those will all impact the reach out at sea of the electromagnetic waves. And of course, the position of the antennas on the vessel. If you have a very high mast of the antennas, you can put them up there. And then you will, of course, have a very nice view over the sea. And if the tower is also high on a hill, that will probably have a positive effect on signal reception. Now, what you see here is a very nice, it's a sailing route of a small pleasure yacht. And you see where the overlap is of the towers. So it's the density of the base stations here that we show. And that when you're in that colored region, then your vessel will have a good connectivity, and it will switch between the towers, roaming.
Yeah. But vessels are not surfing evenly on the water. So there is something we call vertical aperture. Can you tell us more about this?
Yes, Chris, it's a very good and a very important thing because we know this from the maritime industry. We know that the North Sea is not a flat sea most of the time. There are a lot of waves in there, but everywhere in the world are waves. So the ship is constantly rocking. So what does this mean? When you have a very high gain antenna, and that's what I see, don't fall for the high gain in especially in maritime. When you have like 15 dBi, then you know that the vertical aperture, that means the vertical opening angle is very narrow. That means from the slightest wrinkle in the sea surface, your boat does like that, and it shoots over and under the cell tower.
Yeah,
because it's very narrow opening.
Yeah, it's like pointing with a very sharp, let's say, spotlight.
Yeah.
But you're always missing the guy on the stage. Yeah.
Yeah.
Okay.
That's a very fantastic example, Chris. When you have a really focused light, spotlight, of course you see a lot of light, but it's really dense. When you unfocus it, you reach a much broader part of the wall or the person, people. So that's a really good example.
I understand that even on a moderate sea, it's like a 10 degrees difference that the ship rolls, even on, let's say, almost still water or moderate water. How would you put that into terms?
Yeah, you really need to take that into account, because else your router will constantly see a drop. And again, connectivity, drop connectivity. So, and especially to know in the maritime industry, when you have also a satellite connectivity, which costs much more money, when the router sees that it drops 4G, it will switch over to the VSAT.
Yeah.
And then the money it really starts costing. So the more you're on that 4G connectivity, the less you need the satellite and the less the monthly cost will be.
So what I get out of this, I'm sorry, yeah?
Oh, no, please, Chris.
What I get out of this now is that we better use an antenna with a little bit less gain, but have a wider target range. So I can get the signal from the base station and be more efficient with my overall signal.
Indeed, that is it, what we do. That's why we practically never in maritime, we have special antennas go over 9 dBi, because we know after 9 dBi of gain, it gets quite narrow.
Okay. So then we've been talking about installing or the position of the antenna on the ship, and we know there's a lot of stuff going on the ship, and especially metallic elements.
Yeah.
This is the topic I'd like to cover now. Yeah.
So we know RF electromagnetic waves, they travel to the air, they travel to buildings, but there are, of course, certain materials that are having a blocking effect. Yeah. One of these things are, of course, metallic elements. They work as a reflector, so everything that's behind that will not get any signal. So what does that mean for the antenna? You need to take this into account when you install the antenna. We see here an example of a mast. What would be the effect? You see a very nice omnidirectional radiation pattern on the left, That's what our antenna will do. But of course, then the lowest antenna has, of course, to the left, the metallic mast. So it will be blocked a little bit over there. There is a counter effect, which pushes some gain to the other side, which is positive. But of course, there's a negative impact. Known materials to block electromagnetic waves are, for example, metallic structures, and which when we saw the begin slide with the picture of the sailing boat, it's a speedboat on sailing. They use a lot of carbon because it's quite light in material. Carbon is an enemy of RF technology.
Okay.
So that's a good one to know. If you see metallic structures or carbon structures, then you really need to take these into account when you advise the customer. Hey, this would be the best position. I know from experience that they will say, no, it needs to go there. But then at least you can manage their expectations.
Good. So, so we can advise them there and give them hints, or they can ask us about this.
Yeah, you can advise, you can manage the expectations. At the end, the customer decides where it is possible to install the antennas, but at least you told them what would be the best position.
Got it.
What you see here is a very nice example of a 4x4 MIMO setup. For example, 4x4 MIMO, multi-in, multi-out. That's a technique used by the providers, but also about the router manufacturers. So 4x4 MIMO means you have a 5G router. It has 4 antenna connectors, and it can have 4 antennas to receive those signals. What you see here is, of course, you see a mast of a yacht or a cruise ship even, with metallic structures in the middle. So this was good thinking of the installer. I'll put 2 on the left, 2 on the right. So the blockage in the middle is being anticipated because I have 2 on the left, 2 on the right. He's also working with spatial diversity in a vertical way. You see 2 antennas on top of each other left and 2 on the right. What does that mean, spatial diversity? You increase your screen to pick up electromagnetic waves. And on at sea, vertical separation, one on top of the other, is a little bit more important. Why? In a city, electromagnetic waves get a lot of reflections from buildings and other structures. But out at sea, you only have the vessel and open sea. So there are not a lot of things that can reflect the electromagnetic waves. The only thing that can do that is the sea surface. So it goes down and up. So that means it's more important to vertically space your antennas than horizontally. That's why this example is a good example.
Okay, so spatial meaning I put the antennas away from each other at a certain distance in order to be able to split the signals I get from the tower.
Yeah, we advise always when you space them horizontally, we say 70 centimeters at least. And then you're safe for all frequencies. And that's something to do with the wavelength of the frequencies. 70 centimeters is the wavelength of 450 megahertz.
Okay. Yeah? So this is what we also call the isolation.
Yes. Yes. And when you have horizontally spaced antennas, you need more isolation. When you put them on top of each other, have vertical isolation, antennas do not radiate a lot of power up or down. So you can have like 15 centimeters of space between them, and you won't have any interference between the antennas.
Yeah, got it. So when we're installing antennas and routers, it's always the question, where do I install it? And there's also always one topic coming up is, I need 20 meters of cable, or I need 40 meters of cable. And so we all know that it's not good because the cable produces a lot of loss, correct?
Yes, yes, indeed. So what you can see in this slide here, so you have different types of cable. For me, coming from marine connectivity, our standard cable was LMR 400, so the lowest one, the thick blue line, which is a thicker cable, more expensive, but it reduces loss because we had to deal with 10, 15, going to 20. We even used LMR 600, which is very thick and not flexible and not so pleasant to work with. But it keeps the loss to a minimum. So the lower you go in quality or thickness of the cable, the more loss you have. And of course, the higher the frequencies, the more loss you have in longer cables. So we know there's always a challenge, but of course the antenna market has evolved. We will discuss this later in the presentation, but do take care. If you have long distances between the router or and the antennas, or try to look at the position where you can put the router closer to the antennas, or use better and thicker and more expensive cable, because it's very important to know that these LMR, for example, LMR 400 cable 10 meters is also 100 euros. If you have a 4x4 MIMO 5G route, that means times 4, it's 400 euros. So
that's also something I wanted to say. I mean, when you look at this with the 5G router, you have 4 antenna elements, meaning you need 4 cables, all like what, finger thick, and really not nice to work with. And this also causes you need a lot of space for those cables. So it's better, like you say, to put the router closer to the antenna, or even what we will see later, into the antenna, which is a nice idea. So and we can see that here that you developed a high-end product for this purpose, which is the WAVEHUNTER.
This was our first dome solution. The question itself came from the market. Hey guys, can you not think of making something with these and these specs? So we started looking into it, and this is an antenna. It's omnidirectional because it's made for sea, that offshore vessels with a lot of people on there, ferries, cruise ships, big yachts, where we use directional antennas with higher gain and a very nice vertical aperture and horizontal aperture. And we create an array of directional sectors, but by creating the array, it becomes omnidirectional, of course.
And it's quite huge. So what can we say about the size of this?
The size, the diameter is 65 centimeters, and I think the height is about 60 centimeters too.
But it houses up to 3 routers with 2 5G modules, correct?
Depends on which router brand you use, but it can have in total 6 5G modems. But these 5G modems can, of course, be packed in dual 5G routers or even quadruple 5G routers. Of
course. That's. Well, I just want to give an idea about the space we have inside.
It has 4 units in rack height, and it has you can put quite some routers in there.
And here we can understand how many antennas was it? 6 by
24 LTE antennas.
And they are all arranged outside, around, but in 2 stories, correct?
So this way we can, because the antennas we use in there, we already sold over 30,000 units in normal fixed wireless access projects on land together with providers. To increase people's internet at home. So we know what it can do, and then it already has 2 polarizations, and by shifting the lower level a turn of 45 degrees, we can create 4 polarizations, which even decreases the possibility of polarization mismatch, which gives us much more we can get from that signal that's still available there. So this combined with the high gain of the directional antenna, this is the advantage of using directional, you get so many benefits. And then, of course, combining bandwidth of 6 5G modems, it's a real powerhouse solution.
Cool. And we can see that power when we look at the sea trials you made. We have a picture here or a slide here where we can see the results at certain distances. And it's quite impressive, I must say.
And knowing this test was performed, because I told you in the beginning that we're a South African company, and to be honest, there's 4G, even 5G in South Africa, but the infrastructure is not like here in Europe. We're a little bit spoiled. So we have really good infrastructure, and more is being improved on the North Sea, on the Mediterranean, because they know that the marine, after the Suez Canal blockage, And after COVID, people started to really look at, hey, this maritime industry, commercial shipping, is really a big thing in the global economy. So we need to provide as much as possible for these people and for this branch of economy. So South Africa spoken here. You see the red line is the best performing single modem in the WAVEHUNTER. Mm-hmm. And the black line is the combined bandwidth we created at the same position. So what you could see on 10 kilometers offshore, that we had one modem having 173 Mbps download speed. Yeah, but when we combined all the bandwidths together of all the modems at 10 kilometers, we had a fantastic speed of 505 Mbps. Wow. That means a lot of Netflixing for the people, for example.
Yeah.
Yeah. And of course, when you go further away, you see the decrease of the speeds, which is quite normal, because the only thing that are left are the lower frequencies. Lower frequencies, you remember from a few slides ago, lower internet speeds, which is totally normal.
Yeah.
But then the screens are a little bit blocked by, let me close this down. Yeah. What you see then, the results we had at 70 kilometers. In South Africa.
Did you say 70, 70?
70
yeah.
kilometers.
Yeah.
And you see at the end, we still have one modem performing 45 Mbps. And knowing a little bit about sailing routes of a lot of commercial ships, of most yachts, of a lot of smaller sailing, but this is WAVEHUNTER. So let's say yachts and commercial shipping, for example, or offshore vessels working on wind turbines. They are never over that 70 kilometers.
Uh-huh. Okay.
And commercial ships can go over, but let's say 80% of time they're within that 70 kilometers. And if you can then give to corporate business, like the network on the ship, which for the corporate, also for the crew, you can give a little bit of that 45 Mbps, then you will have a very happy crew. And knowing that a satellite connectivity, I'm not talking about Starlink now, a satellite connectivity will give you probably 1 Mbps, maybe 2 Mbps, depending on how much you pay for it. And it comes at the cost of a few €1,000 a month. Then this is really a nice result. And we also have some of our partners having tested for a month Starlink versus the WAVEHUNTER. And what they saw that on average speed, that the WAVEHUNTER had more speed than the Starlink. So that's a very nice thing. So it can do a lot for your connectivity and for your customer. Let's say you have a ferry, a cruise ship, a yacht, then a WAVEHUNTER is really top connectivity solution. And a big advantage, of course, the router is really close to the antennas, which means no long cable lengths. The only thing that's coming out of the WAVEHUNTER is maybe a power cable, and 1 or 2 or 3, depending on how you set it up, a internet cable.
Yeah, good. Wow, that's an impressive product and impressive result you got there. And we have a little sister of this one, which is called the Ripple.
Mm-hmm. We released the Ripple, of course, with the experience, the knowledge, and the feedback of a lot of experienced system integrators that asked us, hey guys, WAVEHUNTER, fantastic thing, we see fantastic results, but it's a very high-end product for really big vessels with a lot of people, big yachts. It's the MSRP is €16,000. Wow. So for a lot of commercial ships, this is way over budget, which we understand. So we asked, guys, can you maybe develop something that is more budget friendly, but still gives us the advantages of cross polarization, getting the routers in there close to the antennas, which cuts back on the cable cost and the loss of the cable. What can you do? So we started developing this Ripple with these comments in our head. So we have a 5G antenna. It has Ripple 8 and Ripple 16. That means 8 antennas, 16 antennas. You have 2 versions. You can have we have 2 GPS antennas in there and 4x4 dual band Wi-Fi in there. Mm-hmm. So what you can do, you have the Ripple 8, you can put 2 5G modems in there, which means 8 antennas. We use cross polarization. We have high gain vertical antennas and lower gain horizontal antennas. So again, we use cross polarization to get the most out of the signal. And we have the Ripple 16, which has room for 4 5G modems. Yeah. So here at the left, you see one of the initial test models. And you see that the base plate is still white. And you see what we did. and then we tested, and then after some practical feedback of the integrators, we created the final versions on the right. Here you see an example of Teltonica routers, which Chris also sells a lot of them. This is the RUTX50, that's their 5G model.
Yep.
So you can really easily place 2 on the base plate, and you see on the left, you see 2 levels. You can also place 2 on the top level. So a max of 4 5G modems in the Ripple 16. The cables are in there, just connecting them. You see 2 Ethernet cables coming out there, going through the cable gland. So a really neat installation and maximizing all the things you can maximize on a clean RF antenna setup.
Yeah.
Yeah.
So we've seen the high-end product. We've seen the smaller Ripple, which is, what would you say, about a third the size of the WAVEHUNTER, maybe?
The Ripple is about 40-45 centimeters in diameter.
Ah, okay.
Which is really good, accepted by the commercial shipping
yes, got it.
market. The Ripple 16 comes at an MSRP at the price of $4,999 without routers, of course, and the Ripple 8 comes at $3,999. We did some investigation. This is a very acceptable price for this kind of solution for the commercial shipping market, because they also understand that cutting away 4 times 4x4 or 5G modem, 4 times that cable we discussed of over 15 to 20 meters also saves them and optimizes the whole setup. So yeah.
Good. Yeah, without going into too much detail, you have a lot of more marine antennas. We see a range of all different sizes and flavors, I would say, with also all possible to hook up to the standard mounting solutions that you offer, like the different brackets, like rail mount, like the flat mount, or like the one that you can, how you call that? Drop away.
I call it the bracket 39, Chris.
Yeah, I know. The bracket 39, which when you want to go under a bridge or so, you can put it away. Is that do I understand it correctly?
Yeah, that's something you can do. You can easily flap it down and up when it's needed.
Flap it down. That was the word. Yeah. Thank you.
I think that's more a Dutch word than it's an English word. But we understand each other.
So yeah, and you have a proven record of success. There's a lot of installations. Here we see one on a container vessel. Yeah.
So what can I tell you a little bit about the top pictures there? These are 2 OMNI 493s, which are our highest gain vertically polarized antennas. The thing is, it's because the biggest answer, right? The nicest answer in RF technology is it depends, because people ask all these questions. It depends. What we want to prove with this, we will never say, hey, these antennas will reach 100 kilometers on 4G. But what it can be, this is north of the Netherlands. This is a ship working on the wind farms, 60 kilometers offshore and more. And they went out to 108 kilometers, and the captain sent us an email. Hey guys, I still have 4G at 108 kilometers.
Wow.
These antennas were just 4 meters above sea level. But of course, the Netherlands has a very good 4G infrastructure. And so this can happen. We will never say, hey, you will easily reach 100 kilometers, but it can happen. This is also a nice one, because the same OMNI 493, they did a trip from Sweden all the way to the Netherlands to Rotterdam, around Denmark, and they never, I think never, let's say 99% of time, were on 4G, which is impressive. When you see close to Denmark, no problem, but then you pass from Denmark to the Netherlands, you cross, you see the corner with Germany, that's quite some distance from sea. It's
like it says, like 60 got it, 60 nautical miles, and never lost connection, basically. And that's very, very impressive.
8 kbps for us at land, it's not really wow, but compared to a VSAT solution of 512 kbps or maybe a megabit, then 8 megabits is a huge difference. So
Then, of course, there's also a very high-end pole mount, or how you call those, Narwhal Series.
The Narwhal Series, named after the element, the animal. Sorry. So the Narwhal also has a big pole on his nose, which he uses for censoring the water and then trapping the fish he wants to eat. Now, Narwhal Series is a different type of antenna. It's a high quality finished antenna, which uses 316 stainless steel in the foot, which is really, protect against sea salt and whatever out there at sea. And the cap is also 316 stainless steel. And we use fiberglass. Why do we use fiberglass? These are big antennas. The lowest one is 1.60 meters, and the highest one is 2.65 meters, where we put 4 high gain elements on top of each other. So the vertical spatial diversity, as we discussed a few slides ago. And of course, we need fiberglass because it's a little bit more ruggedized than the normal ASA plastics we use. And of course, a 2.60 meters antenna will catch some wind out at sea. That's why we do it. But we have great results from them too. And it's really giving very large distances out at sea on 4G.
Yeah, and what can be better than customer feedback on some of your solutions? And here we have a nice customer feedback from a WAVEHUNTER user.
Yeah. This one is not about distance. This is an offshore vessel, which is about, at the moment, working on an offshore wind farm, 25 kilometers offshore from the Netherlands coast, so The Hague. They're working there 25 kilometers, but they reported, and that's so we're not talking about distance, about the quality of internet. You see also Starlinks, they use hybrid connectivity, Starlinks and the WAVEHUNTER. They reported with the WAVEHUNTER 90% of time being able to use the 5G network of The Hague, which is awesome because you're 25 kilometers further.
Yeah.
And they have these incredible speeds. The crew is super, super happy. They can have video calls with the family at home. They can do whatever they want. The only negative effect was they had to buy extra bandwidth with the provider because everybody was using the internet. But this is not negative because they saw a happy crew, and it's cost them more to train new crew and search for new crew than keeping the really experienced crew. So for them, it was a no-brainer.
Yeah. Then for the, let's say, entry level, we have the Epoynt Series, which is a small housing where you can also place a router inside for, let's say, small vessels, small yachts.
Yeah.
And
what it does, it's mimicking the advantages of what we have in Ripple and WAVEHUNTER, but then in a smaller size. And of course, you can easily fit a Teltonika RUTX50 in there. So you don't have the long cable lengths, coaxial cable lengths. You just put up the mast, put the 5G modem in there, come down with an internet cable, and you create great connectivity.
Yeah. Alrighty. So let's see.
This is the use case. Yeah.
Oh yeah, that's a nice use case also for a walk to work vessel.
Yeah. So to be honest, we created the OMNI 900 series, which has fiberglass, the 316 steel, more because the questions came from the yachting business. Hey, can you have this really nice finish? But the first ones that ordered was this offshore vessel, working vessel, which brings the people to the places to work in the offshore wind farms or where cables need to be pulled on the sea bottom. So they were the first to install these with really great results on distance. These are the OMNI 902s. Those are 2 vertical spaced antennas, high gain antennas on top of each other. Yeah.
Well, cool. Thank you. So Birger, we've seen and learned a lot about the fundamentals of antennas, how you see it from Poynting side. I think we learned tons on the different thoughts you have and made into it, and the products you made out of this, which I think is really creative and is really helping the market to bring 4G and 5G internet to the ships of today. I'd like to thank you very much at this stage already for this, for your participants and for your insights here you gave us. It was very, very interesting. And before we head out, I'd like to tell the participants that they can post their questions like afterwards, like in a couple of minutes. But for now, I'd like to thank you very much, Birger.
Yeah, same way. I want to thank you, Chris, the IME team, for the opportunity to speak to your customers and explain a little bit. And maybe also good to know if you're really into project or if you have other questions, we're happy to schedule together with Chris a one-on-one where we can discuss your project or the challenge you're facing. Happy to share the knowledge. That's no problem.
Okay, thank you.